What if I told you that Earth might be harboring an ancient cosmic secret? A primordial black hole from the first moments after the Big Bang, hiding inside our planet's core for billions of years. What if this invisible passenger has been shaping Earth's destiny without us ever knowing it existed? Tonight, as you drift into the deepest mysteries of space and time, we're going to explore one of the most mind-bending discoveries in modern astrophysics. Scientists now believe that tiny black holes, older than the Sun itself, might be living inside planets, asteroids, and even everyday objects around you right now. Before we dive into this cosmic journey through deep time, make sure you're subscribed. Because what you're about to discover will change how you see every rock, every planet, and even the ground beneath your feet. What are primordial black holes? Let's begin this journey by traveling back to the very first second after the Big Bang. What are primordial black holes? When the universe was a chaotic soup of energy and matter, and the first shadows were born. Imagine the universe just 1 second after its birth. The cosmos was nothing like the vast, star-filled expanse you see when you look up at the night sky. Instead, it was a seething cauldron of pure energy, hotter than the core of any star, denser than anything we can comprehend. Today, in this primordial chaos, something extraordinary happened. The first black holes came into existence. Scientists theorize that primordial black holes formed in the first second after the birth of the universe. But these weren't the massive stellar black holes we typically think of, those cosmic monsters, created when giant stars collapse. No, these were different. These were the universe's first children of darkness, born not from dying stars, but from the violent fluctuations of space-time itself. Picture this: the essential ingredient for the formation of a primordial black hole is a fluctuation in the density of the universe, inducing its gravitational collapse. As the early universe expanded at an incomprehensible rate, some regions became slightly denser than others. These dense pockets, no larger than a marble, contained enough matter to collapse under their own gravity, creating black holes that would outlive the stars themselves. These primordial black holes, or PBHs as scientists call them, came in all sizes. Some were microscopic, smaller than an atom, but containing the mass of a mountain. Others were larger, perhaps the size of an asteroid, but with the mass of our moon. PBHs would have much less mass than the stellar black holes later formed by dying stars, but they would still be incredibly dense and powerful. What makes these ancient black holes so fascinating is their age. While the stars we see in the night sky are mere children, perhaps a few billion years old, primordial black holes are older than anything else in the universe, except the cosmos itself. They've been wandering through space for over 13 billion years, silent witnesses to the birth of galaxies, the formation of solar systems, and the emergence of life itself. As you lie here tonight, consider this. These invisible time travelers have been drifting through the universe since before Earth existed, before the Sun ignited, before our galaxy even formed its spiral arms. They are cosmic nomads, carrying within their event horizons the secrets of the universe's violent birth. But here's where the story takes an unexpected turn. For billions of years, scientists believed these primordial black holes, if they existed at all, would simply float freely through space, perhaps occasionally colliding with stars or planets. They never imagined that these ancient shadows might find a way to hide in plain sight, to make their homes inside the very worlds we inhabit. The journey from the chaotic first second of the universe to our modern understanding of these cosmic mysteries is a story of human curiosity pushing the boundaries of what we thought possible. New research suggests that primordial black holes created during the Big Bang could have played a major role in forming the universe's first stars. They weren't just passive observers of cosmic history, they were active participants, shaping the very structure of the cosmos we see today. As we settle deeper into this exploration, imagine these primordial black holes as cosmic seeds, scattered throughout the universe during its first moments. Some would grow into the supermassive black holes that now sit at the centers of galaxies. Others would remain small, wandering through space like invisible ghosts, occasionally encountering planets, asteroids, and other celestial bodies. And sometimes, just sometimes, they would find themselves captured by a world's gravity, beginning a relationship that could last for billions of years, slowly and secretly transforming their host from within. The research proposes thinking both big and small to confirm the existence of primordial black holes, suggesting that their signatures could range from very large, hollow planetoids in space to minute, microscopic tunnels in everyday materials, found on Earth, like rocks, metal, and glass. But how could something as exotic as a black hole actually live inside a planet? The answer lies in a delicate cosmic dance that's been playing out for billions of years, right beneath our feet. How black holes can live inside planets. As we drift deeper into this cosmic mystery, imagine a scenario that challenges everything you thought you knew about planets. What if the solid ground beneath you, the rock-solid certainty of Earth itself, was actually harboring an ancient secret? What if our planet, and countless others throughout the universe, could serve as homes for invisible cosmic passengers? As the universe rapidly expanded after the Big Bang, areas of space may have been denser than their surroundings, causing them to collapse and form primordial black holes, PBHs. PBHs would have much less mass than the stellar black holes later, formed by dying stars, but they would still be powerful enough to fundamentally alter any world they encounter. Picture this delicate cosmic ballet. A small primordial black hole, perhaps no larger than a grain of sand, but containing the mass of a small mountain, drifts through space for billions of years. It's invisible, detectable only by its gravitational effects. A ghost from the universe's violent birth. Then, purely by chance, it encounters a young planet still forming from cosmic dust and debris. The gravitational dance that follows is both beautiful and terrifying. The black hole doesn't simply crash into the planet's surface. That would be too crude, too destructive. Instead, it's captured by the planet's gravity, slowly spiraling inward through layers of rock and molten metal. If the object has a liquid central core, then a captured PBH can absorb the liquid core, whose density is higher than the density of the outer solid layer, explains Dr. Dejan Stojkovic from the University at Buffalo, whose groundbreaking research has opened our eyes to this possibility. Imagine the black hole's journey to the planet's center. It doesn't bulldoze its way through the rock. Instead, it absorbs material as it goes, growing slightly larger and more massive with each piece of matter it encounters. The planet's structure barely notices this tiny intruder at first. The black hole is so small, its direct effect so localized, that the world continues its normal geological processes, unaware of the cosmic passenger now residing in its heart. But once the primordial black hole reaches the planet's liquid core, something remarkable happens. Small primordial black holes could be captured by rocky planets or asteroids, consume their liquid cores from inside and leave hollow structures. The process is incredibly slow, measured in geological timescales that span millions or even billions of years. As you visualize this process, think of it not as destruction, but as transformation. the black hole doesn't violently tear the planet apart. Instead, it quietly consumes the dense liquid core, growing slowly larger, while the planet's outer shell remains intact. Over vast periods of time, what once was a solid world becomes something entirely different. A hollow shell with a small but incredibly dense black hole at its center. The outer appearance of such a planet would remain virtually unchanged. Its mountains, its seas, its atmosphere, everything would look normal from the outside. Spacecraft could orbit it, land on its surface, and never detect the profound change that had occurred within. The planet's mass would remain the same, its gravitational effects on surrounding objects unchanged, because the black hole that consumed its core has the same mass as the material it absorbed. Study suggests that small black holes born in early universe may have left behind hollow planetoids and microscopic tunnels. This research, published just recently, has revolutionized our understanding of how primordial black holes might interact with solid matter throughout the universe. But the story doesn't end with planets. Consider the smaller objects in our solar system: asteroids, comets, even large meteorites. These too could serve as hiding places for primordial black holes. An asteroid might appear completely normal from the outside, while harboring a tiny black hole at its center, slowly consuming its interior over millions of years. The implications are staggering. Throughout our galaxy, there might be countless worlds that appear solid and normal, but are actually hollow shells, their cores replaced by ancient black holes. These cosmic imposters could be orbiting stars, drifting through space, or even supporting life on their surfaces, all while hiding their true nature from any observers. As we contemplate this possibility, consider the profound loneliness of these primordial black holes. They've been wandering the cosmos for over 13 billion years, older than any star, any planet, any form of life. When they finally find a world to call home, they begin a slow process of transformation that will outlast civilizations, species, and entire ecosystems. This brings us to a question that might keep you awake tonight. What if our own Earth is one of these transformed worlds? What if the planet beneath you is not what it appears to be? Could our planet be hollow? As you lie here in the quiet darkness, feeling the solid ground beneath you, consider this unsettling possibility. What if everything we think we know about Earth's interior is wrong? What if our planet, this world that has nurtured life for billions of years, is harboring a secret as old as time itself? For centuries, scientists have painted a picture of Earth's interior based on seismic waves, gravitational measurements, and our understanding of planetary formation. We imagine a solid inner core of iron and nickel, surrounded by a molten outer core, wrapped in a thick mantle of hot rock, all topped by the thin crust we live on. It's a comforting model, solid, predictable, comprehensible. But recent research has opened a door to a far stranger possibility. A theoretical study suggests that small black holes born in the early universe may have left behind hollow planetoids and microscopic tunnels, and that we should start looking within rocks and old buildings for them. What if Earth itself could be one of these transformed worlds? Picture this scenario. Billions of years ago, during Earth's formation or shortly after, a tiny primordial black hole encountered our young planet. This cosmic wanderer, no larger than a marble but containing the mass of a small mountain, was captured by Earth's gravity. Slowly, inexorably, it spiraled inward through layers of molten rock and metal, eventually settling into our planet's core. Over geological time, spans so vast that entire mountain ranges rise and fall like waves, this ancient black hole began. its patient work. If the object has a liquid central core, then a captured PBH can absorb the liquid core, whose density is higher than the density of the outer solid layer, creating a hollow space where once there was solid matter. The process would be almost imperceptibly slow. Generation after generation of life forms would evolve, thrive, and go extinct on Earth's surface, never knowing that deep beneath their feet, a cosmic transformation was taking place. The black hole would consume Earth's molten core bit by bit, growing slightly larger with each particle of iron and nickel it absorbed. But here's what makes this scenario so eerily plausible. Nothing about Earth's surface behavior would necessarily change. The planet's mass would remain constant because the black hole contains the same amount of matter as the core it consumed. Earth's magnetic field might fluctuate, but magnetic reversals are a normal part of our planet's behavior. The gravitational effects that hold our moon in orbit, that keep our atmosphere in place, that govern the tides, all of these would remain exactly the same. From the outside, Earth would appear to be the same vibrant, life-supporting world it has always been. Satellites would orbit normally. The International Space Station would maintain its path. GPS systems would work perfectly. Yet deep beneath the continents and oceans, where no human has ever been and no instrument has ever directly observed, our planet's heart might be empty except for a tiny, incredibly dense sphere of warped space-time. Consider the profound implications of this possibility. Every earthquake that shakes the ground, every volcanic eruption that lights up the sky, every movement of tectonic plates that reshapes our continents, all of these geological processes occur in Earth's outer layers, far above the core. A hollow interior wouldn't necessarily stop these processes. It might even affect them in subtle ways we haven't yet understood. The seismic waves that scientists use to map Earth's interior would still travel through the planet, bouncing off the boundaries between different layers of rock and metal. But if Earth's core were a hollow sphere with a small black hole at its center, those waves might create patterns that we're misinterpreting. What we think is a solid inner core might actually be the walls of a hollow cavity. What we interpret as a molten outer core might be empty space crossed by gravitational fields we don't fully comprehend. As you contemplate this possibility, imagine the loneliness of such a primordial black hole, sitting in perfect isolation, at Earth's center. It has been there longer than life itself, older than the atmosphere we breathe, older than the oceans that cover most of our planet's surface. It has watched the birth of continents, the evolution of life, the rise and fall of countless species, all while remaining completely hidden from view. This cosmic passenger would be the ultimate introvert, affecting our world in ways so subtle that we mistake them for normal planetary processes. The gradual cooling of Earth's interior, the slow changes in our magnetic field, the deep currents of molten rock that drive plate tectonics. What if these are all influenced by the presence of an ancient black hole that has been our planet's secret companion for billions of years? The beauty of this theory lies in its subtlety. Unlike the catastrophic scenarios often portrayed in science fiction, a primordial black hole in Earth's core wouldn't destroy our world. It would transform. It so slowly and gently that life could continue to evolve and thrive on the surface, completely unaware of the cosmic drama playing out thousands of miles beneath their feet. Transitional hook to segment 4. But Earth's core isn't the only place these ancient black holes might be hiding. The evidence of their passage might be all around us, in places so ordinary that we walk past them every day without noticing. Evidence all around us as we continue our journey into the hidden world of primordial black holes. Imagine for a moment that you could see the invisible. Picture the rock sitting on your windowsill, the metal frame of your bed, even the glass of water on your nightstand. What if I told you that any of these ordinary objects might contain evidence of cosmic visitors from the dawn of time? If a small PBH passes through some solid material, it will leave a straight long tunnel of the radius comparable to the PBH's radius. For example, a 10^223G PBH should leave a tunnel with a radius of 0.1 micron. Dr. Stojkovic's research suggests that the proof of primordial black holes might not require billion-dollar telescopes or deep space missions. Instead, it might be hiding in the most mundane objects around us. Think about this. Every day, cosmic particles rain down on Earth. Most of them are harmless, tiny bits of space dust, high-energy particles from the sun, radiation from distant stars. But among this cosmic shower, there might be something far more extraordinary. Primordial black holes so small they're invisible to the naked eye, yet so dense that each one contains more mass than Mount Everest. When one of these ancient wanderers encounters solid matter, it doesn't simply bounce off or get stopped like ordinary particles. Instead, it passes straight through, leaving behind a perfectly straight tunnel that tells the story of its passage. These tunnels would be incredibly thin, far smaller than the width of a human hair, invisible without powerful microscopes, yet perfectly preserved in rock, metal, glass, and any other solid material the black hole encountered. Imagine the journey of such a primordial black hole. It might have been wandering through space for billions of years, a cosmic nomad carrying within its tiny event horizon the compressed remnants of matter from the universe's first moments. By pure chance, it encounters Earth's atmosphere at tremendous speed, perhaps thousands of kilometers per second. The atmosphere offers no resistance to something so small and dense. The black hole passes through air molecules like they don't exist, maintaining its perfectly straight trajectory. When it hits the ground, it continues its journey through whatever lies in its path: solid bedrock, underground rivers, deposits of metal ore. Nothing can deflect or stop its passage. The research proposes thinking both big and small to confirm the existence of primordial black holes, suggesting that their signatures could range from very large, hollow planetoids in space to minute, microscopic tunnels in everyday materials found on Earth, like rocks, metal, and glass. Picture an ancient cathedral, its stones quarried from bedrock that formed millions of years ago. Hidden within those stones might be microscopic tunnels, perfectly straight lines that pass completely through the rock. A primordial black hole could have created this tunnel long before humans existed, perhaps when dinosaurs ruled the Earth, or even earlier, when life was just beginning to emerge from the primordial seas. The tunnel would be so small that even if you could see it, it would appear as nothing more than a hair-thin line. But its straightness would be absolute. No natural process could create such a perfectly linear path through solid rock. It would be a signature written in stone by a visitor from the cosmic dawn. A message that says, "I was here," in a language we're only now learning to read. But these tunnels wouldn't just be in ancient rocks. They could be everywhere. The metal beam supporting your ceiling might contain one, created when a primordial black hole passed through the iron ore while it was still buried deep in the earth. The glass in your window might have a microscopic tunnel running through it, formed when the sand was still on an ancient beach, and a cosmic visitor passed by. Even more intriguingly, these tunnels might exist in everyday objects that have been around for decades or centuries. An old building, constructed from stone quarried long ago, might contain multiple tunnels created at different times by different primordial black holes. Each tunnel would be a frozen moment in cosmic history, a record of an encounter between ancient darkness and solid matter. The search for these tunnels represents a completely new approach to hunting for dark matter and primordial black holes. Instead of looking out into deep space with massive telescopes, scientists are now looking inward, examining the ordinary materials that surround us every day. Study suggests that small black holes born in early universe may have left behind hollow planetoids and microscopic tunnels. Consider the profound implications of this research. If these tunnels exist and can be detected, they would provide direct, physical evidence of primordial black holes, proof that these ancient cosmic objects aren't just theoretical constructs, but real phenomena that have been interacting with matter throughout the history of the universe. The beauty of this approach lies in its accessibility. While studying distant galaxies requires enormous telescopes and years of observation, searching for primordial black hole tunnels could potentially be done in any laboratory with a powerful enough microscope. The evidence we seek might be sitting on a shelf in a museum, embedded in a sample of ancient rock, or even in the walls of the building where you're listening to this right now. As you settle deeper into this exploration, consider that you might be surrounded by evidence of cosmic history. Every rock, every piece of metal, every fragment of glass around you could potentially contain a microscopic record of encounters with primordial black holes, tiny time capsules that preserve the signatures of the universe's most ancient travelers. Transitional hook to segment 5. But what happens when these cosmic visitors don't just pass through, when they decide to stay? The slow consumption that follows is a process so gradual, so patient, that entire worlds can be transformed without anyone noticing. How black holes eat planets. From inside, in the quiet of this moment, as you drift deeper into cosmic contemplation, imagine witnessing one of the universe's most patient and profound transformations. This isn't the violent destruction we typically associate with black holes, those dramatic scenes of stars being torn apart by massive gravitational forces. Instead, this is something far more subtle, far more gentle, yet ultimately far more complete. The slow consumption of an entire world from within. Small primordial black holes could be captured by rocky planets or asteroids, consume their liquid cores from inside, and leave hollow structures. This process unfolds over geological timescales so vast that they dwarf human comprehension. To understand it, we must think in terms of deep time, the millions upon millions of years during which continents drift, mountains rise and fall, and entire species evolve and vanish. Picture a primordial black hole that has found its way to the center of a planet. Unlike the chaotic, high-energy feeding frenzies of stellar mass black holes, this consumption is measured and methodical. The black hole sits in the planet's core, like a cosmic pearl, surrounded by molten rock and metal, beginning a meal that will last for eons. The process starts with the densest material first. If the object has a liquid central core, then a captured PBH can absorb the liquid core, whose density is higher than the density of the outer solid layer, explains Dr. Stojkovic. The heavy elements, iron, nickel, and other metals that sank to the planet's center during its formation, are exactly what the black hole finds most appetizing. Imagine this cosmic dining experience unfolding in slow motion across millions of years. Each atom that crosses the black hole's event horizon adds infinitesimally to its mass, while the planet's core gradually becomes less dense, less substantial. The process is so gradual that the planet's surface experiences virtually no immediate effects. Life could evolve, flourish, and develop complex ecosystems, all while unaware of the fundamental transformation occurring miles beneath their feet. As centuries become millennia, and millennia become millions of years, the hollow space around the black hole grows larger. What once was solid becomes empty, creating a spherical cavity at the planet's heart. The black hole itself grows slightly more massive with each bit of matter it consumes, but it remains incredibly small compared to the hollow space it creates. The beauty of this process lies in its perfect balance. The planet's total mass remains unchanged because every atom that disappears into the black hole still contributes to the world's gravitational field. From the outside, the planet appears completely normal. Its moons continue their orbital dance. Its atmosphere remains stable. Its magnetic field might fluctuate, but not disappear entirely. But inside, a magnificent transformation is taking place. The solid core that once generated the planet's magnetic field through the movement of molten metal is gradually being replaced by something far stranger. A hollow sphere with a tiny, incredibly dense object at its center, surrounded by nothing but empty space and gravitational fields that bend reality itself. Consider the implications for any life that might exist on such a world's surface. Millions of generations could rise and fall, build civilizations, develop science and technology, even study their own planet's geology, without ever detecting that their world has become fundamentally hollow. The seismic waves they use to map the planet's interior would still travel through the remaining shell of rock and metal, creating readings that seem to indicate a normal, solid core. This cosmic sleight of hand could be happening throughout the universe right now. Countless planets, some perhaps harboring life, others barren and cold, could all be undergoing this slow transformation. From our perspective, they would appear to be normal worlds, some rocky like Earth, others gas giants like Jupiter, all following predictable orbits around their stars, all hiding their hollow hearts from any observers. The process isn't limited to planets. Asteroids, comets, and even large moons could serve as hosts for these patient primordial black holes. An asteroid that appears solid and unremarkable might actually be a hollow shell, its interior consumed over millions of years by an ancient, cosmic visitor. When such an asteroid passes close to Earth, we see only its outer surface, never suspecting the empty space within. The timeline of this consumption varies depending on the size of both the black hole and its host. A very small primordial black hole might take billions of years to hollow out a planet-sized world, while a larger one might complete the process more quickly. But, in all cases, the transformation occurs so gradually that it's invisible to any observers who don't know what to look for. As this slow consumption continues across cosmic time, the hollow worlds created by primordial black holes become like cosmic shells, maintaining their external appearance while hiding their true nature from any casual observation. They are the universe's secret transformed worlds, carrying within them the evidence of encounters with ancient darkness that occurred when the cosmos was young. The most haunting aspect of this process is its inevitability. Once a primordial black hole settles into a world's core, there is no force in the universe that can stop the slow consumption that follows. The planet becomes a clock, counting down geological time as its interior gradually disappears into the cosmic visitor that has made its core into a home. Transitional hook to segment 6. This raises a crucial question. If hollow worlds and microscopic tunnels surround us, how can we detect them? Scientists around the world are now developing ingenious methods to hunt for these cosmic ghosts, and their discoveries might revolutionize our understanding of the universe itself. As we delve deeper into this cosmic mystery, imagine yourself in a laboratory where scientists are conducting one of the most unusual treasure hunts in human history. They're not searching for gold or precious gems, but for something far more valuable: physical evidence of cosmic visitors that have been hiding in plain sight for billions of years. The search for primordial black holes represents a complete revolution in how we hunt for dark matter and cosmic phenomena. Traditional astronomy looks outward, using massive telescopes to peer into the depths of space, hoping to catch glimpses of distant black holes consuming stars or colliding with each other. But Dr. Dejan Stojkovic's groundbreaking research has turned this approach inside out, suggesting that the evidence we seek might be sitting right here on Earth, embedded in the most ordinary materials around us. Picture a team of researchers carefully examining a piece of ancient granite, using electron microscopes powerful enough to reveal details smaller than a virus. They're looking for something that would be invisible to the naked eye. Perfectly. Straight tunnels with diameters measured in fractions of a micron. These tunnels, if they exist, would represent the fossilized tracks of primordial black holes that passed through the rock millions or billions of years ago. The theoretical study suggests that small black holes born in the early universe may have left behind hollow planetoids and microscopic tunnels, and that we should start looking within rocks and old buildings for them. This opens up an entirely new field of cosmic archaeology, where researchers examine terrestrial materials for evidence of extraterrestrial phenomena. The search methodology is both elegant and challenging. Scientists must first identify materials that have remained undisturbed for long periods. Ancient rocks from deep geological formations, metal samples from old mines, even glass that has survived for centuries without being remelted or reshaped. Each sample must then be carefully sectioned and examined under powerful microscopes, looking for the telltale signs of primordial black hole passage. What makes this search so difficult is the incredible rarity of such encounters. Even if primordial, black holes exist in the numbers that some theories suggest. The chances of any particular piece of material containing a tunnel are astronomically small. It's like searching for a single specific grain of sand on all the beaches of the world, except the grain of sand you're looking for is invisible and might not even exist, but the potential payoff is enormous. If researchers could definitively identify even a single tunnel created by a primordial black hole, it would provide direct physical evidence for phenomena that have only existed in theoretical models. It would prove that these ancient cosmic objects are real, that they've been interacting with matter throughout the universe's history, and that they might indeed be components of the mysterious dark matter that makes up most of our cosmos. The search isn't limited to terrestrial materials. Scientists are also developing new ways to detect hollow asteroids and planetoids in space. Using advanced gravitational measurements and seismic analysis techniques, researchers hope to identify celestial bodies that appear solid from the outside but are actually hollow shells created by primordial black hole consumption. Consider the technological challenges involved in this cosmic detective work. The tunnels left by primordial black holes would be so small that they approach the limits of what even our most powerful microscopes can detect. The equipment needed to identify these features must be sensitive enough to distinguish between natural microscopic formations in rock and the artificial-looking perfect straightness of a primordial black hole track. Modern laboratories are now developing AI-assisted analysis systems that can examine thousands of microscopic images, looking for the geometric perfection that would characterize a primordial black hole tunnel. These computer systems can identify patterns that human eyes might miss, scanning through enormous databases of material samples with inhuman patience and precision. The international scientific community is taking this search seriously enough to dedicate significant resources to it. Research groups across multiple continents are examining everything from meteorite samples to cores drilled from the deepest parts of the Earth's crust, all hunting for evidence of these ancient cosmic visitors. As you contemplate this scientific treasure hunt, consider that every rock formation, every ancient building, every piece of metal that has existed unchanged for long periods might potentially contain evidence of encounters with primordial black holes. The proof we seek could be hiding in a museum specimen, in the foundation stones of an ancient cathedral, or in a sample of metal ore that has been sitting in a university collection for decades. Hollow worlds in space as we drift further into the cosmic depths of this mystery. Imagine looking up at the night sky and realizing that some of the solid objects moving through space might be nothing more than empty shells, hollow worlds that appear normal from the outside while hiding profound secrets within their transformed interiors. Our solar system is home to hundreds of thousands of asteroids, ranging from tiny chunks of rock, barely larger than boulders, to massive worlds hundreds of kilometers across. We've always assumed these objects are solid throughout, formed from the same processes that created the planets. Cosmic debris that never quite managed to coalesce into full-sized worlds. But what if some of these familiar celestial neighbors are actually hollow? Their interiors consumed by primordial black holes over millions of years. Small primordial black holes could be captured by rocky planets or asteroids, consume their liquid cores from inside, and leave hollow structures. This process wouldn't be limited to large planets. It could affect any solid object in space that encounters one of these ancient cosmic wanderers. Picture an asteroid drifting through space for millions of years, appearing completely unremarkable to any observers. Its surface is scarred by impact craters. Its rotation is predictable. Its orbit follows the same gravitational laws that govern all celestial mechanics. But deep within this seemingly ordinary space rock, a primordial black hole has been slowly consuming the asteroid's interior, creating a hollow chamber that grows larger with each passing century. The transformation would be virtually undetectable from the outside. The asteroid's total mass would remain the same because the black hole contains the same amount of matter as the material it consumed. Its gravitational effects on other objects would be unchanged. Spacecraft could fly past it, land on its surface, and drill into its outer layers without detecting the hollow interior hidden beneath. This scenario becomes even more intriguing when we consider asteroids that have been targets of space missions. The research proposes thinking both big and small to confirm the existence of primordial black holes, suggesting that their signatures could range from very large, hollow planetoids in space to minute, microscopic tunnels in everyday materials. Consider the asteroid Bennu, which NASA's OSIRIS-REx mission visited to collect samples. What if detailed analysis revealed that Bennu has an unusually low density for its apparent composition? What if seismic measurements suggested the presence of hollow spaces within? Such discoveries wouldn't necessarily prove the presence of a primordial black hole, but they would raise fascinating questions about the asteroid's internal structure. The implications extend far beyond individual asteroids. Throughout our solar system, there might be hollow moons, hollow comets, and hollow chunks of space debris, all carrying within them ancient black holes that have been their invisible companions for eons. Some of these objects might even be in stable orbits around planets, serving as natural satellites while hiding their true nature from the worlds they orbit. Think about the asteroid belt between Mars and Jupiter, that vast ring of rocky debris that represents the remnants of a planet that never formed. Among the millions of objects in this cosmic junkyard, how many might be hollow shells created by primordial black hole consumption? These transformed asteroids would be indistinguishable from solid ones using most conventional observation methods. Detection of hollow asteroids would require new approaches to astronomical observation. Scientists would need to look for subtle anomalies, objects whose density seems too low for their composition, whose gravitational effects don't quite match their apparent mass, whose internal structure creates unusual responses to tidal forces, or seismic activity. Advanced space missions might eventually be designed specifically to identify these hollow worlds, Imagine spacecraft equipped with gravitational wave detectors sensitive enough to identify the unique signatures of small black holes, or drilling systems capable of detecting sudden changes from solid rock to empty space as they probe an asteroid's interior. The asteroid mining industry, which may develop over the coming decades, could inadvertently make some of the most important discoveries in this field. When robotic miners drill into what they expect to be solid metal-rich asteroids, they might occasionally encounter hollow chambers that suggest the presence of primordial black holes. Consider the broader implications for our understanding of the solar system's history. If primordial black holes have been randomly transforming solid objects throughout the cosmos, then the process of planetary formation and evolution might be far more complex than we currently imagine. Some worlds might have been hollow for most of their existence, while others might be in various stages of transformation that won't complete for millions of years. The moons of the outer planets present particularly intriguing possibilities. Objects like Europa, Enceladus, and Titan have complex internal structures that we're still trying to understand. What if some of these moons harbor not just subsurface oceans, but also hollow chambers created by ancient primordial black holes? As you contemplate this cosmic game of hide-and-seek, imagine that some of the most familiar objects in our night sky might be cosmic imposters, hollow worlds that maintain perfect disguises while hiding their transformed nature from any casual observers. The asteroid that occasionally passes close to Earth might be mostly empty space. The comet that puts on a spectacular show might be a hollow shell with a tiny black hole at its heart. Universe's missing pieces as we approach the end of our cosmic journey through the hidden world of primordial black holes. We arrive at perhaps the most profound mystery of all: the invisible architecture that holds our entire universe together. Everything you can see in the night sky, every star, every galaxy, every cloud of cosmic gas represents less than 5% of all the matter and energy in existence. The remaining 95% is hidden from our eyes, detectable only through its gravitational effects on the visible universe. Scientists call this invisible component dark matter and dark energy, and despite decades of searching with the most sophisticated instruments ever built, we still don't know what it is. But primordial black holes might provide a tantalizing answer to at least part of this cosmic puzzle. Imagine the universe as a vast cosmic web, with galaxies strung along filaments of invisible matter like dewdrops on a spider's web. This hidden scaffolding guides the formation of stars, shapes the evolution of galaxies, and determines the large-scale structure of everything we see. Without dark matter, galaxies would fly apart, stars would never form, and the universe as we know it simply couldn't exist. For years, physicists have proposed that dark matter consists of exotic particles that rarely interact with ordinary matter. Hypothetical objects with names like WIMPs, weakly interacting massive particles, or axions. But despite building ever more sensitive detectors and conducting ever more sophisticated experiments, we've never directly detected a single one of these theoretical particles. This is where primordial black holes enter the story as potential game changers. As theoretical study suggests that small black holes born in the early universe may have left behind hollow planetoids and microscopic tunnels, researchers are beginning to consider whether these ancient cosmic objects could account for at least some of the universe's missing mass. Picture the first moments after the Big Bang, when the universe was a seething cauldron of energy and matter, undergoing rapid expansion. In this chaotic environment, fluctuations in the density of space-time could have created primordial black holes of all sizes, some as small as elementary particles, others as massive as stars, and everything in between. Unlike the exotic particles proposed by other dark matter theories, Primordial black holes would be made of ordinary matter compressed to extraordinary densities. They would interact gravitationally with everything around them, shaping the formation of cosmic structures through their collective gravitational influence. Yet they would be individually invisible, detectable only through their effects on space-time itself. The beauty of this theory lies in its elegance. Instead of requiring the existence of entirely new types of matter that we've never observed, the primordial black hole theory suggests that dark matter might consist of familiar objects, black holes, that formed under the extreme conditions present in the universe's first moments. As you contemplate this possibility, consider the implications for our understanding of cosmic history. The primordial black holes that might be hiding inside planets and asteroids throughout our solar system would represent just the smallest fraction of a much larger population scattered throughout space. The vast majority of these ancient objects would be wandering freely through the cosmos, invisible and undetectable except through their gravitational effects. New research proposes thinking both big and small to confirm the existence of primordial black holes, suggesting that their signatures could range from very large, hollow planetoids in space to minute, microscopic tunnels in everyday materials found on Earth. This range of scales reflects the incredible diversity that primordial black holes might display throughout the universe. Recent gravitational wave detections by facilities like LIGO and Virgo have revealed the collisions of black holes with masses that are difficult to explain through conventional stellar formation processes. Some of these events might represent the mergers of primordial black holes that have been orbiting each other since the universe's youth, slowly spiraling inward over billions of years before finally colliding in spectacular displays of gravitational energy. The search for primordial black holes as dark matter candidates has opened up entirely new approaches to understanding cosmic mysteries. Instead of looking for exotic particles in underground detectors, scientists are now examining ordinary rocks for microscopic tunnels, studying asteroid densities for signs of hollow interiors, and analyzing gravitational wave signals for evidence of ancient black hole populations. Consider the profound interconnectedness this theory suggests. The hollow asteroids drifting through our solar system, the microscopic tunnels potentially hidden in rocks all around us, the invisible dark matter that shapes the evolution of galaxies. All of these phenomena might be different manifestations of the same underlying reality. A universe populated by primordial black holes created in the cosmic dawn. If this theory proves correct, it would represent one of the most significant breakthroughs in our understanding of the universe's fundamental nature. The search for dark matter, which has consumed the careers of thousands of physicists and the resources of nations, might find its answer not in exotic new physics, but in ancient objects created when the universe itself was younger than a heartbeat. We drift toward the end of our cosmic exploration. Imagine that every invisible gravitational tug that holds galaxies together, every unseen force that guides the formation of stars, might originate from countless primordial black holes scattered throughout space and time. These ancient wanderers, born in the universe's first second and destined to outlive every star, might be the hidden architects of everything we see in the cosmos. The primordial black hole that might be hiding in Earth's core, the microscopic tunnel that could be embedded in a rock on your windowsill, the hollow asteroid drifting through the darkness between planets. All of these are potentially connected to the grandest mystery in all of science, the invisible foundation upon which our entire universe is built. In the end, we might discover that we live in a cosmos where the most important players are also the most hidden, where ancient shadows from the universe's birth continue to shape reality in ways we're only beginning to understand, and where the key to cosmic Mysteries might be hiding in the most ordinary places we never thought to look. As we reach the end of our journey through the hidden world of primordial black holes, remember that the universe is far stranger and more mysterious than we ever imagined. These ancient cosmic visitors, older than the stars themselves, might be hiding in plain sight all around us, in the rocks beneath our feet, in the planets above our heads, and perhaps even in the very core of our own world. If this exploration through deep time has opened your mind to the cosmic mysteries that surround us every day, make sure you're subscribed and hit that notification bell, because the universe is full of secrets waiting to be discovered. And together, we'll continue uncovering the hidden wonders that make reality far more extraordinary than any fiction. Sweet dreams, and remember, you're never truly alone in this universe. Ancient shadows from the cosmic dawn might be closer than you think.